All right, we're going to be doing reaction rates. The goal of this thing is to observe the effects of concentration in reaction rates and to develop a mathematical relationship between concentrations and reaction rates. We're also going to determine the order of reactions and also to observe the effects of a catalyst. So here's what you're going to need. You're going to need some hydrochloric acid. You're going to need some sodium thiosulfate, some distilled water, preferably in the little dropper bottle, a 96 well reaction plate, plastic toothpick, small beaker, a stopwatch, white paper, and graph paper. I just have a white piece of paper. You can just use a regular printer paper or whatever. And what you're going to want to do is we're going to want to put X's right underneath these circles in wells A1 through A4. And the way to do that is I'm just going to take my paper. I'm going to kind of line it up right here, and I'm going to leave a little bit of space up on top. And in that space up on top, I'm going to put little X's right at where it lines up with the dots. So here's what I got. These little X's, and I have them above the circles. And hopefully, if I did it right, there we go. I can line it up so that way the X's appear inside the circles. Obviously, they're not inside the circles, they're on the paper, but what I'm going to do is I'm going to do an experiment, and then there's going to be a precipitate that forms, and that precipitate will make it cloudy, and so I won't be able to see the X's. And so the experiment is going to be to measure how long this thing takes. This thing's all about timing, so you're going to want to have your stopwatch ready. I don't have a stopwatch here because I'm not doing the full experiment. I'm just showing you how to set it up. If I had the stopwatch, that means I'd be doing the experiment. I want you to be able to do it yourself. So anyway, what we're going to do is we're going to put different concentrations of sodium thiosulfate into the wells. We want all the wells to be filled with 5 drops of something. So what I'm going to do is I'm going to put 5 drops of pure 0.1 molarity sodium thiosulfate in well A1. So that'd be 1, 2, 3, 4, 5. Now I'm going to put 4 drops in well A2. 1, 2, 3, 4. 3 in well A3. 1, 2, 3. 2 in A4. 1, 2. And 1 in A5. There we go. Now I accidentally moved the sheet of paper. So what I think I'm going to do, just to make life easier on me, is I'm going to line it up. Then I'm going to draw a little line right here. That way, if I ever move it again, I can just line it up with that little line, because these X's will become so that way you can't see it. Now, I told you there needs to be 5 drops in each of these wells. So, and again, I apologize for the camera angle cutting off the top of my head, and I know it looks kind of weird, but you'll want to see more of the table than my face, so that's kind of why we did that. All right, what I'm going to do is, I know I have pure concentration of sodium thiosulfate in the well number 1. Over here, I only have 4 drops, so I need to put 1 extra drop in there. In well A3, I only have 3 drops, so I need to put 2 extra in there. Okay, I'll put 4 in here. No, 3 in here. 1, 2, 3, and 4 in well A5. 1, 2, 3, 4. Okay. So now each well should have exactly 5 drops in it. And they all look like they're about the same. All right. Now what I'm going to do is I'm going to steer this mixture up by stirring it with a plastic toothpick. But I don't want to just go from A5 and then go straight into A4 because there's some of the sodium thiosulfate on here. I'm starting off with A5 and working my way down to A1 because I'm going to try to go from the least concentration to more concentration as we go. And in order to deal with that, what I have my handy dandy distilled water. I'm going to spray down the toothpick, shake off the water, and that way I know that I've, to the best of my ability, cleaned off the sodium thiosulfate. And then I'm going to stir this one, spray, shake, stir, spray, shake, stir, spray, shake, and stir, spray. I like to clean off all of my instruments right after I'm done using them. That way I know that I don't need to clean it off again when I pick it up, so I want to use it immediately. Now I'm going to put 3 drops of hydrochloric acid in each of the wells and start the clock. I'm going to see exactly how long it takes for these precipitates to not be visible. I think what I'm going to do is I'm going to try to do it as quickly as possible. I'll start off with A5 and I'll work my way down A4, A3, A2, A1. Now what you're going to have is 1, 2, 3. What you're going to have, and you're going to need to figure out exactly how you want to do this, is you're going to have a little stopwatch right here or a cell phone, and you're going to want to click start, and you're just going to watch. Did I do this wrong? Let's see, 2 and well. Oh, I did this a little bit wrong. I apologize. Apparently, you only need to go from, you start with 5 drops in A1, then go 4 drops in A2, then 3 drops in A3, and then 2 drops in A4, but you don't need to go to A5. Apparently I set up one extra experiment for myself. I apologize. So I did this a little bit wrong. Basically, you just need to rewatch this video and take out one of the steps that I did, which is deal with A5 at all. So okay, is it turning? Oh, it's starting to be hard to see that first X. I can tell you that. And I keep shaking it, and I realize, you know what I'm doing is I'm introducing another variable. And this is good because honestly, this is the first time I'm doing this specific experiment, and I can show you some pitfalls. I wouldn't shake it, or maybe what I would do is I would shake it the whole time. I'm just trying to shake it just to see if it will actually turn cloudy in the first place. But what you want to do in your experiment is don't touch it, just watch it. And you can see, I can see that first X is starting to get a little bit cloudy and hard to see. You don't want to shake it because notice how I was shaking it and looking and shaking it and looking and shaking it and looking at it. I'm introducing a variable, and what I'm doing is I'm making it harder for myself to control the experiment because it might depend on how vigorously I shake it. Imagine if I took a little fire and I heated these things up. Maybe that might cause the reaction to go faster or slower. We don't know. And we don't want to say, hey, the reaction rate depends on both the concentration and also maybe the temperature and also how much you shake it. We want to investigate each of those variables one at a time. Yeah, I can start seeing a difference here. So start recording when you think that, hey, I cannot see this X anymore, and this is the numbers I record. Some of you might say, hey, I can still very faintly see the X. How do I know when to stop the clock or record the time or whatever? And my answer to that is, you know, it's really on you. It's to your best discretion to figure it out. Now, I've been sitting here talking this whole time, and I think I have some more time, just a little bit more time. But what I don't want to do is I don't want to let that precipitate form and just hang out there. I don't want to go away and then come back and clean it off at the end of the day after the experiment has been done and going for like 2 hours or whatever. The reason being is because that precipitate might actually just stick to the bottom of that plate, and it's going to be hard to wash that thing out. So, clean up, pretty simple. You just pour it into the sink. You'll make sure you use a lot of water to dilute that sample going down so it doesn't cause any harm to the environment. Answer the questions, do the lab report, and I hope that answered a lot of your questions. Let me know what you need. Okay. Aloha.